Okay, so today we're going to be talking about section 5.3. And so I think the big thing is we're going to be writing the equation of lines, and we're going to use scatter plots. We're going to draw a line of best fit. And so we got some vocab about what we're doing today. Okay, so when you look at a bunch of points, okay, and um, we're not writing an equation just like with one letter. Like sometimes you're like, oh, x plus 5 equals 8. Okay. We've got two variables every time we've got an ordered pair. Okay. And so we're going to call this bivariate data. Why are we calling it bivariate? Because it's two for bi variable. Okay. So two variable data. So we're going to talk about the variables x and y and write an equation with that. If you are going to have graph all the points like from like science class, we could call that a scatter plot. And if you look at your scatter plot, you'll notice that in general, your graph could be going uphill from left to right. As you go to the right on your graph, as you go to bigger values of x, you'll notice that your y coordinates actually are getting higher and higher. Okay, and so this is called a positive correlation. It also has to do with um, things both increasing. So if you're talking about this is how many hours you study, and this is going to be your grade. Okay. Notice as your hours of studying increasing, in general, your grade probably goes up. Okay. Not directly linearly, but it will hopefully increase a little bit. Or the number of hours you work, maybe it will be people work different number of hours per the week at their jobs and how much money they earn. Okay. And then the negative correlation would be as X increases. So like you work different hours here, this could be free time. Okay. So how much free time you have left. Okay. And so that's kind of a silly example, but on video games, if you spend an exorbitant amount of money on or time on video games, it's possible that your grade might go down. Okay. A little bit, you still could have a high grade. A lot, you might not have the best grades. We'll see. Okay, so that would be a negative correlation. As X increases, your Y value gets lower and lower and lower. As you increase how many hours you spend on your phone, perhaps your grades will go downhill. Okay. And then sometimes they're not related, meaning graph your hair length, okay, and your grade. Okay. Your hair length probably doesn't impact how good of a grade you have in any class. Okay. So and negative would mean as X increases, the Y values are getting lower and lower and lower. Positive would be as X increases, your Y value decreases or increases. Sorry. So you can see the trend, okay, of the data. Okay. Is it increasing or decreasing? Or is there none? Okay. So this is the trend. A line of fit helps you kind of see like, oh, look, this line right here is going uphill. And we're going to write the equation of that line. So y equals mx plus b. And so if you can draw a line that kind of goes to the data, we're going to draw a line there and we're going to find the equation of that line. We can't find the equation between every point because there's too many points and they don't form a straight line. So we're going to draw a line in the data and find that equation. Um, and then the next two are kind of weird. Linear extrapolation. So basically, we're going to use a linear equation. We're going to say extrapolate. So if you extrapolate, like say, hey, if I do this and this, let's think what would happen over time in the long run, what's going to happen. So if you're like, oh, I know it's going uphill, let's go way out here and see what happens. Let's kind of predict what would happen further. So extrapolation would be going beyond it. So like extra credit would be beyond the norm. Extrapolation would be extrapolating your equation and say, in the far distant future, what's going to happen. And then linear interpolation. I'm not sure how to pronounce that. It would be inside the data, maybe there's not a point there, but can I find what, like something, predict within the data what would happen? Okay, say that I don't have a data point there. What would happen in between, on that line, in between some of the data points I do know? And so inside of it would be using a linear equation to predict values inside the data range for points that you don't actually have. Extrapolation would be beyond your data. Okay, so which of these is positive? Which one's negative? Well, this would be negative. Why? As the years increase, notice the number of landlines or phone lines are decreasing. Okay, so as X increases, Y is going reducing or decreasing. This has no correlation. Okay, you could draw the trend is going downhill. The line of best fit would be going a negative slope. Right here, the trend line could be like this. This would be positive. Okay, positive correlation. In general, it's going up. That line of fit kind of is going uphill slant. Okay, and so the trend is increasing. There's a positive correlation. Okay, how would you write the equation of this line? Well, you'd get out your ruler and you draw a line. And I'm obviously not using a ruler because I'm on my screen. And the thing is, what you most want to do is pick 2 points that kind of go through the data. And we try in general to pick points from our data set, okay? And I'm going to tell you which ones to use. It says use 1020 and use 5080, okay? I'll tell you which ones. And we're going to use those because some of them are not really on the line, the trend line, or the line of fit. The trend is going uphill. The line of best fit is a positive. We're going to write the equation of that line of fit. And so we're going to do 80 minus 20. 50 minus 10. And so a lot of times we get a decimal. When we do word problems, make this a decimal. So it's 1.5, okay? For slope on word problems, okay? Why? A lot of times they're pretty janky. And then we're going to use a point. So y minus 20 equals 1.5, x minus 10. So 1.5x minus 15. Solve for y equals mx plus b. So that's our equation. And so we're talking about as a baby goat increases pounds, okay, gets bigger and bigger, it uses more milk. Okay, so what if you had a 17-pound goat? Okay, so if X is 17 pounds, so this would be in interpolation. So 17, we're going to figure out where would that be? We're going to do Y is equal to 1.5 times 17 and add 5. We're going to use our equation. We're not just going to guess it. And then we're going to figure out 17-pound goat. It will use 30.5 ounces of milk. Okay, so that would be inside, so enter. Okay, and what if it was 55 pounds? Okay, and that would give us 87.5 ounces. And that would be outside of our data, so that'd be an extrapolation example, okay? Okay. So the trend is going uphill. The line of fit is what we drew there. It has a positive correlation. The more it weighs, the more the amount of milk increases, the Y value increases. Okay, and so we can plot these as well. So if you plot some of these points, 10 is going to be at 24, 40 is 45, 50 is 52, 80 is 77, and 100 is 88. And so it's increasing as well. So if we did a ruler to kind of draw through this, again, we're not going to connect all the dots because they are a scatter plot, not a straight line. And so the 2 points we're going to pick are going to be 1024 and 188. Why did I pick those? Because they're pretty close to the line. Okay. The points closest to the line would be a good choice. So 10, 24, and 188. So 88 minus 24 over 100 minus 10. That gives us 64 over 90. Divide them, and it's approximately 0.71. So get a decimal. And then what we're going to do is we're going to do y subtract 24 equals 0.71, and then x minus 10. If we distribute and solve, you get 0.71x minus 7.1 equals y minus 24. So add 24 to both sides. So y equals 0.71x, and then plus 16.9. And then we're going to use it, okay? What if he studied 30 minutes? Okay, so this is the minutes of studying. So if x is 30, so 0.71 times 30 and add 16.9. So it'd be interpolation. And so that means that he would get a 38.2%. If he studied 110 and then plus 16.9, we're going to get 95%. So this is a positive correlation because in general, as he studies more, his grade goes up. And then also, you can do interpolation or extrapolation, depending if you want to predict within the graph or outside of it. All right. That is the end of my lesson. Thank you so much. Hope you have a great day. Let's see if I can turn this off.